Okay, so this week is quiz 3, and that's going to cover 2.7, 2.8, and 3.1, their respective units. I have this page for like what to memorize, just in case you wanted to go through that. I'm going to try and do pages like that from here on out, but we'll see what happens. So our first question is going to be using the limit definition of the derivative, that's this formula, to find f prime of 2 where f of x equals 2 divided by 4x minus 5. So this unit introduces the concept of derivatives, and one of the ways we can find the derivatives is by using this equation as really an alternative way to write our function. So first thing we would do is we would write down the limit definition of the derivative, which is this. And then we would say, I like to go off to the side, I like to pull off to the side here and say, well, all right, what is f of x plus h? So that's 2 divided by 4, and then the x plus h is in parentheses, right? Because everywhere we see an x, we need to plug in an x plus h. So we need to distribute that 4 to both of the terms, both the x and the h, not just the x. Otherwise, we'd get an incorrect answer. So then we can plug that into this formula, and we can say, okay, 2 divided by 4x plus 4h minus 5 minus f of x, and f of x is just literally that, so we just write that. And so when you're dealing with these kind of problems, there's really 3 different strategies you can use. There's the conjugate, there's the like denominators, and then there's the expansion. And this one is going to be like denominators, and we can kind of tell that because, right, we have a denominator here and a denominator here all within our numerator. And if we want to simplify this at all, we're going to need to get one single denominator up there. So one of the ways we can do that, or the way that we can do that, is by multiplying each thing by the denominator of the other thing like this. So this is just getting like denominators, which I'm sure you know how to do by now. This was like some prereq stuff too. You've seen this before, I'm sure. So, okay, so then this becomes 2 times 4x minus 5 minus 2 times 4x plus 4h. And then, what is that, minus 5? All divided by 4x minus 5 times 4x plus 4h minus 5. So then we need to distribute all this stuff in the numerator, and sorry, this is all over h, that we can bring that h into the regular denominator like this. It makes it a lot simpler to write. So then we need to expand the stuff in the numerator, so that becomes 8x minus 10 minus 4x minus 4h plus 10, because that negative 2 gets distributed to every term within this parentheses, right, not just the first. And then the denominator stays the same. Generally speaking, we don't touch the denominator. We just keep that h out front, and then when it cancels out, that's when we do stuff. So speaking of canceling out, this negative 10 is going to cancel with this positive 10. And I did something wrong. Oh yeah, this is supposed to be negative 8x, not 4x. Same thing here. So this negative 8x cancels with this 8x. So then we are left with the limit as h approaches 0 of negative 8h divided by h times 4x minus 5. And then I won't bother saying that whole thing. It's kind of redundant. So then those h's cancel out, and when the h's cancel out, that's a sign that you're ready to plug in 0 for h. So let's go ahead and let's do that. Negative 8 divided by 4x minus 5 times 4x plus 0 minus 5, and then that's negative 8 divided by that's just that same thing, and then we're looking to find f prime of 2. So we plug in 2 for x, so 4 times 2 is 8, minus 5 is 3, and then all that times 8 minus 5, so that becomes negative 8 divided by 3 times 3, which is negative 8/9. So our answer is going to be negative 8/9. Honestly, you could have plugged in the the two for x all the way up here and just done it that way. For some of these problems, you'll be asked to find it at a specific point, at which point you can use this, or you can use that alternative limit form where it's like the limit as x approaches a. But sometimes you'll be asked, like in this question, you'll be asked to find the derivative as a function. And for that case, you'll have to do all of this. You'll have to solve the general derivative. You won't be able to just solve it at a point. But for the purposes of this question, either way is fine. Okay, so now moving on to the next question. Use the limit definition of the derivative to find the velocity, where the position is defined as s of t equals the square root of 5t. So we start with our limit definition of the derivative function, which is limit as h approaches 0 of f of x plus h minus f of x all over h. So our f of x is 5t, or square root of 5t, so f of x plus h is the same thing, right, as s of t plus h. You know what, I'm going to solve this equation using x's because I feel like it'll be easier to read, but we will give our answer in terms of t. So let's be the square root of 5 of x plus h, which equals the square root of 5x plus 5h. So then we plug that into the formula. So that's going to be the square root of 5x plus 5h minus square root of 5x all over h. Remember, we're using x's instead of t's just for readability's sake. So here, now remember, we've got our three things. So we've already, and as just as a little hint, I've given you one example per three different things you can do. So we've already done the like denominators. So now we can either expand or we can use the conjugate. And anytime you see the square, or generally speaking, when you see the square root, you're probably going to be doing the conjugate. So when we multiply by the conjugate, we multiply by the same thing as the numerator, but we swap the term of the f of x. We swap the sign on that term. So we're multiplying by this. And if you remember, the magic of the conjugate is when you FOIL, right, a strategy for simplifying, or when you multiply two binomials, FOIL helps you expand them. But the beauty with the conjugate is you get the outside and the inside to cancel out. So you're left with 5x plus 5h because that's the result of the two first terms multiplied together, right? These two terms, because the square root just kind of gets canceled out. And then you've got a minus 5x because that's the result of a negative 5x, or negative square root of 5x divided, or times a negative square root of 5x times a positive square root of 5x, because you get that negative sign and then the square roots just cancel out. And this is all over h times the square root of 5x plus 5h plus 5x. So then this 5x cancels with this negative 5x, and then this h will cancel with this h. So we are left with a 5 divided by square root of 5x plus 5h plus square root of 5x. And yeah, that's pretty much it. So we would say v of t, and then we'll now swap our x's out for t's. And that would be our final answer there. And then if we were asked to give units, which you probably will be, it would be meters per second. Acceleration is meters per second squared, and position is meters, and then velocity would be meters per second. So units are pretty important. They'd probably be a point on a quiz and or an exam. So now, if you're asked to use the limit definition of the derivative to find the equation of the tangent line of f of x equals x squared minus 9x, where x equals 2, this is how you would do it. So we would start by writing our limit definition of the derivative. If you can't tell, this is a pretty important formula to memorize. So then we would say, all right, f of x plus h equals x plus h squared minus 9 times x plus h. And our last strategy that we haven't used yet is to expand. So if you haven't guessed already, that's what we're going to be doing here. And all that really means is we take this stuff and we just kind of stretch it out a little bit. So when we do that, we get x squared plus h squared plus 2xh. And if you don't feel comfortable with that, you could just write it as x plus h times x plus h. And then you could do the FOIL there, and you would get the same result as this. So then 9 minus 9x minus 9h, because we have to distribute that negative 9 to both of the terms in the parentheses. So then, and while we're at it, let's just put this all over. Let's put it into our limit definition of the derivative, because negative x squared minus 9x, right, this is going to be our f of x, and then all divided by h. So now we're looking for some things to cancel out. Firstly, oh, I see the problem. So I forgot to distribute my negative. So we've got minus, and then f of x is x squared minus 9x. So because we are subtracting, right, this negative sign here is the same thing as this negative sign here. But we are subtracting the entire f of x from this, right, not just the first term. So we have to make sure to put our f of x in brackets here so that we remember to distribute this negative to both terms in there. So then that leaves us with a negative x squared and a positive 9x. So then the 9x, positive 9x, cancels with this negative 9x. This negative x squared cancels with this positive x squared. And then we are left with, and right, this is still the limit as h approaches 0. So we are left with the limit as h approaches 0 of h squared plus 2xh minus 9h all over h. You can factor out an h from each of those terms in the numerator if you want. I'm just going to cross them out. And so we are left with, the one in the denominator, of course. That's what the whole point is. So then we are looking at the limit as h approaches 0 of h plus 2x minus 9. And of course, now that we've got our denominator to cancel out, we can plug in 0 for h. So we're going to be looking at 2x minus 9 as our derivative. So now we are looking for the slope, or we are looking for the tangent line where x equals 2. The slope of our tangent line, or our f prime of 2, is going to be when we just plug in 2 into this formula. So this is our f prime of x. So f prime of 2 is going to be when we plug in 2 to that, which is going to give us 4 minus 9, which is going to give us a negative 5. So to get the equation of the tangent line, we need to plug this into point slope form, which, if you remember, is y minus y1 equals m times x minus x1. And so m is going to be, you might have guessed, negative 5. X is going to be 2, because it's the x value that they give us. So a negative 2 will do a double negative with the negative sign here, and it will become positive. And then y1 is the y value that we get when we plug in 2 to our regular equation, not the derivative, right? What we get when we plug x into the derivative is negative 5, right? That's our m, that's our slope. But what we're looking for is our y1, which is what you get when you plug in x1 into the base equation, which is x squared minus 9x. So f of x equals x squared minus 9x, so f of 2 is going to be 2 squared minus 18, which is going to be negative 14. So then we just plug in negative 14 there. The negative makes that do a double negative thing. So this would be your answer. You could simplify it into slope-intercept form if you really want to, or you can leave it like this, totally up to you. I guess just in the name of time, I would suggest leaving it like this, so that way you don't do more work than you have to. So, but that is the final answer that you would get there. So, and then we're going to do the same exact problem just with the power rule to illustrate how much easier it is to do it with the power rule. So the power rule is just you take your exponent, you bring it down, so 2x, and then you drop the power by 1. So 2 minus 1 is 1, so that's just 2 times x. And then the derivative of 9 times x is just the constant, so just 9. And then so that's our f prime of x. So then f prime of 2 is, and you'll notice, right, that's the exact same equation we got here through significantly less effort. So we would get negative 5. So that's how you do it there. Yeah, so it's, if you have a question where you can use the power rule to check your work on the limit definition of the derivative, I highly suggest doing the power rule first. My first step, if I ever saw this question on a quiz or an exam, my first step would be to use the power rule to figure out what my answer actually should be. So that way I know what answer I'm supposed to get when I do the limit definition of the derivative. So, and then this is just a pretty much every derivative you can think of problem. Here, I'm actually going to add one more in there. Okay, so then, with derivatives, you just take it term by term. So here, you bring the power down, so that's 3 times 7, p, and then 3 minus 1 gives you 2, so which simplifies to 21p squared. 5 divided by 2, p to the second power can be rewritten as negative 5p to the negative 2, right? Because you can bring that p squared up into the numerator, but when you do that, you have to take a negative exponent. But we can do the power rule on that, and then we get a positive 10p to the negative 3, right? Because we bring that negative 2 down, it multiplies with a negative 5 to give you a positive 10. And then we have to subtract 1 from the power. Negative 2 minus 1 is negative 3. So that's how we get negative 3 for an exponent there. Similarly, we can rewrite this 8 times the fourth root of p as 8p to the 1/4 power. And then we can do the power rule on that. We bring down that 1/4, so that becomes 1/4 times 8 times p. 1/4 minus 1 is the negative 3/4 power. So then this can simplify to 2p to the negative 3/4 power, which itself, we can bring that p into the denominator because it had a negative exponent. Negative 3/4 power becomes a positive 3/4 power, but in the denominator. Right here, the derivative of the cube root of 2, that's just 0 because this is a constant. Our variable is x, and if you don't see any of your variable anywhere in the term, the derivative of it is just 0. Negative 9 to the x, right? So if you remember this formula right here, the derivative of the thing when we have x in the exponent is just going to be ln of the base, which is 9, times the thing again. So that would be our derivative there. The derivative of e to the x is e to the x, and since that 3 is just a constant coefficient out front, we would just leave it there. So the derivative of negative 3 e to the x would just be negative 3 e to the x. And then the derivative of 7p, right, we just get rid of the variable, and it is 7. So that would be our long-winded answer there. Although I think this is a good problem because it generally covers pretty much all of the bases with regards to derivatives you could be asked.